So we are recording here. And all right, there we are. We're live. All right, so lecture one, the introduction. I guess a little bit about me. I usually tell this story. How many folks also have me for graphics this semester? Anybody in here? No? Okay, cool. So I can tell the story at least once without, who I am. And then some of you folks I might have had in 5008 as well. But so maybe you've seen the story, but I got interested because of games originally and wanted to learn how to program them. At some point in my sort of teenage years, I was spending more time trying to, build or break the games I was playing than actually just play them. So I said, how do you do this? And I sort of learned, you have to learn programming and 3D art and all these sort of things that got me interested. So kind of went on doing that. So I spent sort of my early career writing tutorials and, sort of my introduction to teaching, I guess, as well. I always put that out as a challenge here. If you can find my tutorials online, they're still there somewhere if you want to, see what I was doing. And then just some other notes about me. I went to Ohio State for computer science. Grew up in Ohio, so from the Midwest there. And it was there at one point, somebody put out a job posting for research in gaming. And I said, that's great. I can do something that involves gaming and help people, at least allegedly. And so I learned about medical visualization and some of these other sort of more serious applications I could apply my skills and did that. And somebody told me I should do a master's and a PhD degree. I had no idea what that was at the time. I thought PhDs for medical doctors, so that was a whole journey if you're interested in the research route. Some of you might be someday. Of course, you're all in master's program or upper level undergraduate. And anyways, my research and sort of professional studies have led me to sort of systems, graphics-y performance stuff throughout my career. And here's some of the places I've worked. Some, recognizable. All of them, of course, I was doing some sort of software engineering. That was sort of in my title, what I was doing. Most of them tend to be sort of in the domain of gaming, graphics, or sort of compilers in those domains. And you'll find that's where some of the examples from this course come from, because I like to pool, real stuff that you'll get to work on. All right, so places where I worked on software, yes, everywhere. And I still do actively consult, so I try to stay fresh too. And of course, I'm a Husky with all you folks. All right, so but I'm not going to be the only person involved in this course. We have 4 teaching assistants. They're part of the course staff. Will be working with us. We'll get you introduced throughout the semester. I'll try to find some pictures of them as well. Right. Okay, and as I mentioned, I'm your option this semester for software engineering. And as the rumors are, yes, we do it in C++. Other instructors will do it in a range of Java, TypeScript, JavaScript. The language doesn't really matter, though, too much. I guess C++ is going to push us in one sort of direction of what our sort of client tells us to do, in a sense. But I think that'll also be a good experience for you to learn why a language is chosen for what application and how you can apply it. I think that'll be great. Okay, so what is this course? Well, it's a software engineering course, so I always try to find some sort of formal definition of what this means. Software engineering can be a very broad term. So IEEE, which is a professional organization, has defined it as the application of a systematic, disciplined, quantifiable approach of the development, operation, and maintenance of software. That is the application of engineering to software. Okay, so software engineering, I guess, sort of self-explanatory. So what's in the name here? As folks mentioned when I asked what you're excited about, software engineering to me means some of these things like learning design patterns, but not only learning the design patterns, but knowing when it's appropriate to apply them to a given problem and what trade-offs you're making. It could be things like how you organize your code, and that means sort of the algorithms and sort of how you're typing things in, but also the sort of let's talk about the sort of physical structure. Where do your source files go? How do you sort of make things in a nice way that can be maintained over a long period of time. It's not uncommon for code bases to be 20 or 30 years old now, especially if you go to a bigger, longer-lived company. And then, of course, we're going to try to learn how to write better code, too. Some strategies for that. Okay, so we're going to study and build some software, some real-world use cases as well. That's part of the software side. And then the engineering, building something, as I mentioned, we're going to try to build a portfolio piece. That's for you guys to take forward for your internship, co-op, full-time job searches. And that's the engineering part. All right, so course content-wise, roughly this is what it looks like. Our sort of developer ecosystem, C++, version control tools, Git primarily. We're going to learn about build systems, so maybe you've seen Make, but some other tools on top of that. We've got to cover some of this stuff in the software engineering lifecycle. That's essential agile, but other applications. How many people have heard the term agile or worked in an agile place? Yeah, so most folks. How about the term waterfall? I'm sure it's similar. Okay, yeah, so a majority of folks. But part of the deal with a course project is you'll actually get to choose. I think a lot of times agile has been the hot word for the last, 10 or 15 years, but it's not always the right way to approach a problem. So we'll sort of learn, again, trade-offs. So then, again, some of the other things, design patterns, requirements, how those will help with testing, different design principles, and testing and debugging. All right, so one thing that also makes this course interesting, as we do sort of a show of hands type of exercise like we did, is some of you have maybe been working professionally for a few years. Some of you are looking for your first internship. So there's going to be a range of folks, but I think everybody's going to learn something new in this course. I think that's totally okay. In fact, I'd be very surprised if you didn't learn something new. Then you can test out and come TA or teach the course or something. So how we're going to sort of organize the course is sort of structure in the way actually that I've been working in sort of my consulting operations where we're going to have some sort of company or client that we're working for and break you into a team of four. Roughly 3 to 4 people. And since you're not the CEO, you're not going to get to pick your teammates. The company is going to have its own constraints as to why you should use C++, in particular modern C++, as your language, as well as some other companies' sort of pipeline and their tools. So I hope this will give you sort of a, just realistic scenario of how the software engineering process works. And you're going to be, the company is giving you enough money. Well, there's no money. I'm not going to give you anything. That would be nice. But for 8 weeks, you have a funding. So that's going to be sort of the structure. So a significant portion of this course, I would say about at least 7 weeks, probably closer to 8 weeks, is going to be working on a project, again, building something. And then we'll have some sort of final presentation during the last week where you get to present what you've built. If we're legally allowed to have food in the classrooms and these sort of things, we will do something, or grab and go donuts or something at the end, and it should be a lot of fun. All right. So note on teams, maybe I gave the answer to this, but why do you think I'm going to give you pseudo-random teams and just sort of pick and choose randomly? Some people are opposed to it, but
In real life, you don't pick your teammates?
Yeah, in general, you don't get to pick, right? Unless you start a company or maybe bring somebody aboard, but again, it's part of the experience. And again, as folks have many different experiences, I think you'll learn from each other just as much as you'll learn from me from different skills or things that you can bring in. So that's sort of the goal there. Obviously, if you have some sort of constraint I should know about, like, hey, Mike, I have a full-time job and I'm only available on Tuesdays at between these hours, I'll try to make it logistically work in that sense. That can be reasonable, but otherwise, pseudo-random. All right, so I want to go ahead and introduce us to the website. I think a lot of folks have found it. A lot of folks have already started downloading the assignments, which has been great. I've deleted all of your repositories, though. So just to put everyone on an even ground, where is the website? So if you haven't done anything at this point or seen this page, that's where everybody should be. If you've already looked, that's great too. Teaching section, Foundations of Software Engineering, and here's the course web page. There's going to be in the top left here is where all these recordings are going to go. They're going to go in a giant YouTube playlist for both our section and the Thursday section as well. So that's where you'll be able to find everything. Probably most important things here are the quick links here. So the Piazza board, office hours, and we'll have a Teams channel. And then our roadmap. So just sort of one by one. Piazza, if you haven't used, it's a pretty good forum board for asking questions privately and publicly. I'll talk a little bit about some logistics there, but to make sure that you have joined. For office hours, the game plan is this semester to do them all virtually. Some TAs might be available for more physical presence if you do want to meet. I'm going to leave that at their sort of discretion. I've actually found virtual office hours have been working better because then we can sort of screen share and see your code without, doing this sort of awkward leaning over laptops and these sort of things. I've actually found it more efficient. So what you'll do for office hours is you'll find, whoever. So for instance, me at the top. Let's go over here for FSE. Some of these slots. Tomorrow I'll open up once I finalize my schedule, and then you'll just type in, your name, and if you want, you can give me an idea of what you're working on. Lab 6, trouble with, whatever, and that'll help sort of also give me a idea of what I should prep for as well. But that's it. You get, one of these slots. Usually, try to get people, one or two at a time and consecutively. And you're welcome to have multiple people sign up too if you want to sort of work together or collaborate on a specific problem. But that's it. And then week by week at the bottom left corner here, there will be a week of September 12th, 19th, and so on to sign up for. So I'll be on here. All of the other teaching assistants will be on here as well. And then we'll have a Teams link here that you just click on. If you have any trouble figuring this out, of course, just email, post on Piazza, or whatever. And for some reason, if none of these times work for you, just let us know, and by appointment, we'll find something. Alrighty. Oops, so that's office hours. Let me undo that stuff. Well, I'll do later. Okay, so other things. So that's office hours, then we'll have Teams, of course. But the other sort of key piece is going to be our schedule roadmap here. Again, you can click on each of these buttons here and you'll see sort of the outline. But it'll also display all of the assignments, the due dates, and the labs that we'll be doing in this class. For folks who have taken any of my other classes, whether that's 5008 or something else, it's going to be structured very similar to how you're sort of used to. Lab every week to sort of apply what we've done. And then assignments that are due roughly every 1 to 2 weeks or so. And that'll be sort of the first portion, and then we'll transition into this project mode, basically. We're just working as a team. All right, so let's go ahead and click on one of these modules here. So this is our resources. We'll have today's video will be posted here. Helpful readings that you can do before class. Most of these center around sort of Git. If you're also wanting to follow along with how I do things, I tend to work in the terminal, most analytic systems, so there's some videos here that you can check out. Slides if you'd like to follow along on the right side. And every class will also have an in-class activity as well. Now, in-class is very loosely defined for this semester. This is just something I want you to complete within a week. So by the time you come next week, please click on this in-class activity. Today is just sort of a survey to get to know you, but Usually it'll be a very low stress sort of quiz, if you want to think about it that way. Just capturing what was the golden nugget. So, for instance, in one of our next lectures, I might talk about design patterns. I might ask you what a design pattern is. You'll say, it's a blueprint to solve some sort of problem. It's going to be very low stress. If you were paying attention during the lecture, you should be okay. And you can look at the slides, right? You have a week to fill this sort of quiz out. But that's how the in-class activities work. I use them to sort of gauge temperature as far as how well people are doing, and if I'm losing people, if I see only half the class, finished it for some reason. All right, so that's sort of the logistics on each module, and that's what those will look like. Other course information, I think folks know where they're at. Here's my contact information, email, and so on. Here, all the teaching assistants as well. And then their emails, just add, at northeastern.edu there if you need to get in contact with them. Teams is also good, but I think Piazza is always the preferred communication mode rather than directly messaging people on Teams at all hours of the days or email. For that, let's see, required materials, I'll get to that in a moment. About this course, just some information, again, I think everybody knows where they're at, but basically this is a project-based course, and our objective is to build things. So you can read through the specifics of some of these things here. And as mentioned, it'll be in C++. Again, if you're anxious or nervous about that, my expectation is no C++ starting with today. So I'm going to give you a little bit of a crash course, introduce the language gently, and then we'll proceed from there. As far as books and resources, nothing required. This free C++ tutorial is pretty good. It'll be one of many that we start off with. And I can recommend this API Design for C++ book. I brought it with me today. This is my reading on the train as well. I like to read through this. This is a pretty good book. It's by a gentleman who was working at Pixar for a while, and he talks about how he built and thinks about different application programming interfaces in C++ specifically. And they talk about design patterns and all sorts of stuff. So this is the one I'd recommend if you want to get a text, but you don't need to. Right. So with that, some course policies here before we get into it, just to get everybody on the same page. So let's see, if you're, let me just start from the top here. Just on academic integrity and non-discrimination stuff, we like to have a very welcoming classroom. Again, if you've taken other classes with me, we try to be friendly, but I've never really had a problem with it. But still want to, always create a culture where we can share ideas, both in person and online, just thinking about how we talk to people or respond and our sort of tone on Piazza and these kind of things. Again, I haven't had any problems with this, but just want to, continue that trend. If you have any questions or concerns, just feel free to reach out about that. But the policies are otherwise listed here. With academic integrity stuff, usually, in the very rare cases that I've had, it's usually because somebody's really falling behind and something else is going on in your life. So just please reach out, if you're taking 5 classes right now and they all have finals on the same day or whatever, that could be very stressful. So please just let me know, if that happens to be the case before you think about, copying and pasting code or these kind of things. For the makeup policy, if you're doing some sort of school event, a conference, a varsity sport, whatever, those are excused. Just kind of let me know. Otherwise, we're going to use a token system here. So basically, what this means is in your GitHub repository, and I'll show you this, you get 3 sort of extensions that you can use. You don't have to tell me why for any reason. You just extend your assignment or your lab, and then you're good to go. And usually, if you're going to think you need more than 3, then something else is going on, and then we can talk about, whatever at that point. But, sometimes you just need a day off, or you're traveling, or, you have something fun to attend to. So 3 extensions, no questions asked. Let's see. Otherwise, if stuff's really getting late, it's 10% per day here. Let me highlight this, which isn't too bad, but you want to make sure it's on time. And try to use the extension system as fairly as possible. You'll see the policy. In fact, let me bring it up. But I've had all these different bullet points because it's kind of interesting. Folks will come up with, well, can I trade some tokens for this assignment or give them to my buddies? And it's kind of interesting, this sort of economy that forms. But I don't know. Just try to use it, as it's intended. And I try to be reasonable, right? I think in all my classes, I just want people to learn and become better engineers and learn this stuff. So there's a sort of logistical have to move everybody along part, but I understand. Your assignments are your currency and you want to do well, so I'll support that. So speaking of which, accessibility-wise, Northeastern has great resources in Dodge Hall, the Disability Resource Center, if you need anything, any accommodations or those kind of things. I'll start by asking the first thing is, can folks hear me okay through the mask so far, especially in the back? Okay. If you can't for some reason, just give me an ear or, wave at me. I'll do the best I can to speak loudly at the least. But if there's other accommodations, whether it's with the recording, whatever makes your life easy, just feel free to privately, address those with me. WeCare is another great resource at the university if you're having any sort of hardship, and that's a free resource, so definitely take advantage of it. Okay, lateness and attendance. Again, folks are going to do well who come to class, or obviously if you can't make it to class, there's recordings. Try to give yourself some structure and just watch the recording at a regular time or as soon as possible if you can. Just try to keep up with the course. On wellness, just my personal note that I remember being a student, it wasn't that long ago. When I was an undergrad, I was working multiple jobs and a full-time schedule, and multiple clubs, and some of you have families and all these other things to balance too. So, please take care of yourself. If there's something going on, that's always most important. As important as I think software engineering is, you can always revisit design patterns and learn them tomorrow, right? If something really important is going on. So please take care of yourself, and feel free to talk to me or any of these other resources. Alrighty, grades-wise, here's the breakdown for assessment stuff. So we'll have our in-class activities, just to kind of keep track of everybody. We're going to have in-class labs as well. Again, this in-class is sort of with a air quotation with it, in the sense that I guess we'll just talk about some of this. Let me address that in a moment, but there'll be in-class labs basically due 1 week later, just like any of my classes, but there's going to be a lot of flexibility with this, which is a bit of an experiment. So I'll leave you on that cliffhanger. There's going to be an exam. It's going to be online in a few weeks' time, so I'll help prepare you for that. Not too high of a percent, but I found folks actually like going through this process of studying for an exam. It's supposed to be, again, low stress and to make sure that you're keying in on the ideas that you should be. We'll have about 4 assignments that you'll do individually, so they're worth about 5% each, and then the majority of your time, again, with the final project. All right, and here's the grading scale. I'll never make this harder, meaning a 99 will never become an A. I'll never, make it harder, but, maybe a 94 will be an A or whatever. But generally, this is what holds throughout the semester. And then you're going to see my list of bullets of things that have actually happened that I have to sort of address here, One student, first thing, walked in, not even hello. Professor, can I get an A in this course? I was like, maybe, yeah. Let's see. We'll adjust the best we can if we have sick days, these kind of things. So just keep an eye on the schedule otherwise. Your code has to compile, and it has to come in on time. So just some policies there. Again, just with the logistics of having about 100 students, we got to try to move things along. Again, this is sort of for you folks, right? Your grades are your currency, and you place the value there, right? You want to do well and sort of get that feedback. So you're welcome to sort of challenge your grade, but you have to do that within 1 week of when you get the grade back. When it's the last day of class and you're asking me to regrade assignment 1 to just get a few points, that's really hard from an instructional sort of mindset, because when we were grading that, we were grading all the assignments fairly, 10 weeks ago with a rubric in mind. So please, if you're going to challenge something, 1 week after your grade is actually posted. Grades are posted to Canvas, and that's basically all I use Canvas for. Everything else otherwise is on this website. If anybody is waitlisted, hang tight. We'll see if we can get you in the course, and just try to follow along with the content and the deadlines. If you are waitlisted, just let me know. It's a little bit of a gamble, but usually we can get you in. There's no extra credit assignments either, but if you do a fantastic job on your project or the assignment and go above and beyond and show your enthusiasm, you can get extra points that way. But we're not going to create extra assignments otherwise. But I do actually look for, like, if you did an awesome job in your project, we'll give you 101 or whatever % plus. Let's see, other important notes. Lab time, again, I'll talk about that in a moment. I have this thing about, like, no Facebook and stuff. I actually don't care so much. I just don't want you to distract others. And that said, I actually encourage laptops if you want to be on, following along, doing notes. If I mention something cool here and you go on a tangent and sort of follow, some interesting algorithm or thing that we talked about, that's fine too. But just try to make this software engineering time. All right, last bit here. I'd like to see everybody at office hours at some point, just to get to know you, what you want out of the course, who you are, your goals. I always learn as much from you folks as you'll learn from me. I hope this semester. So yeah, just definitely, so where my office is. It's going to be virtual this semester. But it's also good practice just to get used to approaching other professors, managers someday, these kind of things, just have discussions and to push yourself to do that. The meeting can be as short as 2 minutes. I usually ask you what program you're in, background, if you've done co-ops, and that can be it too. But if you'd like to talk about more things or ask me anything, that's the purpose of that meeting. Alrighty, so questions on sort of the policies bit here. Put up here. Some logistics. We'll have some more logistics stuff to go through, but
How much collaboration is allowed in assignments, if any?
yeah. So let me get to that in the slide here on collaboration. Let's see. All right. So we navigated the web page. Let me just hop to it here. I guess it's a few slides away. So this lab portion, or in-class lab thing that I was talking about, let me highlight it here in your grades. So in-class. So in-class activities, you should do on your own. I'm going to do a bit of an experiment this semester where for labs you can collaborate as much as you want with anybody. So that means you could all as a class, including with the other section, all be working on Lab 1 simultaneously, if you wanted to. Now it doesn't mean still that, you say, it's your week, and then that person does it, and then you all copy and paste around it. I agree that's kind of smart, economically and stuff. But everybody should learn it. But that being said, I want to encourage an active Piazza. We always have one, but I'm going for like super activity, just getting people very interested in labs and collaboration. And why did Mike put this in the support code here? And not having just me to be the one to answer it always. So a lot of collaboration on the labs. Everybody still has to do it and complete it. You'll have your own private repository you'll be working on, so you'll have to do it anyways. But you can have a lot of collaboration there. In each of the labs and assignments, you'll have a little thing in your assignment that says, who did you collaborate with, whether it was me, whether it was the whole entire class. If somebody organized a review session on lab 1 and you put that in the notes, that would be fine as long as you disclose it. For the exams, there, no collaboration. Assignments, you'll do individually for the most part. When we get to the project, the second half of the class, you're going to be in your team of 4. For some of the later assignments that are part of the project, you 4 will be working. There might be an occasion I might experiment with this where you'll work with another team at some point, but this should be a pretty collaborative class overall. And again, it's a little bit dangerous as an instructor, but use your own sort of insight, right, to what you should be learning, and I'll make sure we sort of push that way. But this is the experiment this semester. All my classes, the labs are going to be completely collaborative. And that also frees me to do other more interesting things like if people are really struggling on lab 2 or whatever, I can spend time making a YouTube video about it, making another slide set, improving the lab or whatever for that. Other questions, comments on policies, experiments we should try? Okay. All right, let's get out of here and keep moving along. So the website, laptops are fine. Any laptops, fine. Any operating systems, fine. I will sort of push folks towards a Linux environment and a VirtualBox environment throughout the semester. It's not going to matter as much this first week or 2, but I'll be helping sort of set up everybody on a common environment shortly. If anybody does need a machine, we've got some strategies from Corey as well. Yeah.
What are your thoughts on like WSL? If we had Windows, would you prefer?
So the application that we're going to be building is graphical. So I think the new WSL being the Windows subsystem for Linux, running Linux on your Windows machine, I believe supports graphics. I've got to test it out on an actual application. It should be fine. What it's going to end up probably being at that point is more talking with your team of 4 and making sure everyone can run code that you write. But it should be fine for weeks 1 and 2, let's say.
That's just so will the Mac is F1 chip affect that?
Yeah, so the new M1 Macs are different architecture. So on VirtualBox, for instance, there are some problems. We'll work through them. We've made it, it should be natively on a Mac. It'll still be fine, worst case, but I'm going to try to get everybody on Linux anyway. But if you've got an M1, it shouldn't be a problem. I've got one, so I'm testing on a M1 Mac as well. It's my backpack. Let's see, other course text, which I mentioned. This is the one I recommend if you're going to read along as well. Teaching style, again, hands-on class. We're going to be building things, so lots of labs, assignments, projects, lots of coding and these kind of things. Just for my sort of personal perspective, again, ask as many questions as you would like. If you haven't sort of gotten that, again, I want Piazza to be active. Lots of question asking, answering by you guys, by me, and so on. But I don't see that as a problem. Other things you don't have to worry about. I never randomly call on anybody, so if you're anxious about that, I'll never do that as an instructor. So come to class, relaxed, and just ready to learn. It says I try to avoid, but I will never do that because I hated that in class. And then, of course, come to office hours. Come talk to me virtually. I prefer Piazza over email, just because I get probably 100 a day, or so. So Piazza is a little bit better. It helps me filter. Again, helps the course staff answer questions maybe faster than I can. If you do have something in private that you want to talk to me about, email is fine for that. But otherwise, I prefer Piazza. I tend not to prefer random Teams messages either. So Piazza is good. Unless it's something, use your judgment if it's urgent. Let's see, other teaching things. I break all the PowerPoint rules, as you might have noticed. There's lots of text on slides and these sort of things, but I think that provides sort of more value. So don't take any notes as far as presentations from me. These are the sort of what's a good PowerPoint. But I hope these will be a good deliverable if you're just sort of, again, trying to organize yourself for how to be successful in this class. Going through the slides is a good place to sort of follow along with the content and the readings provided as well. All right, so last sort of logistics things, of course, we've all got masks on, right? The COVID-19 world, elephant in the room. The university set expectations that we wear masks. I think technically faculty don't have to if we stay away, but I would like to, so just to set that. If you need a break, if it's getting really hot in here or whatever, feel free to, go outside or whatever. No problems there. I'll never take offense to that. We are also in a 6 to 9:15 time slot, so if you're just really hungry or whatever, you're welcome to. Again, that's why we're recording everything. So you can take a break. I'm not going to try to cause any problems there. We'll social distance the best we can, I know this classroom's kind of tight. Again, if you have concerns about that, feel free to take care of yourself. Again, there'll be no pressure here. Stay home if you're not feeling well or whatever. There will be always recordings and slides. The worst case, too, you can look at my last year's lecture and it'll be about 80% similar to, if you want to work ahead or whatever. Because if you're going to be out for some reason. On my end, then, nothing's thus going to require you. I'm not going to grade you. I'm not going to be, sort of looking with my binoculars to see who showed up to class and, anything like that. In that sense. So in-class activities, again, you have a week to do. In-class labs, you have a week until they're due. And then here's the experiment. Where labs can be worked on with anyone, as many partners as you want, remotely or in person. All right. So again, obviously, if you don't feel comfortable with something, let me know. The situation in the world is fluid. It's always changing. So does anybody have any questions they'd like to address about this? I don't know if your other classes talked about it. The sort of obscure situation. Don't have to say anything out loud, but if there's something you need me to do, just let me know. And that's all I got there. All right, so just lighten the mood up a little bit here. In the bottom right corner, this is Ollie, who we house sit every once in a while. He carries not one, but 2 toys at a time. So. Alrighty. All right. So with that said, let's go ahead and begin, and then we'll take a little break here in a little bit. Or any last second or whatever course questions, course policy things. Alrighty. Let's begin. So quick, I guess raise of hands. C++. Who's used it? Okay, so a good portion of folks have played around with it. What have you heard about the language? What is it used for? What do people say? Yeah, thoughts?
I typically use it for a lot more math because of the math libraries in it.
A lot of math libraries, yeah. So sometimes you're sort of the ecosystem that's sort of built around the language has been developed. So yeah, depending on, especially in a machine learning domain or something. Or graphics and so on. Was there a hand here as well? Same thing, math libraries, yeah. You guys must be taking another course together. Yeah, in the corner.
Use it in embedded systems.
Yeah, embedded systems. So does this mean like Arduinos and sort of breadboards, that level, or watches or other devices? Yeah. Yeah, so as we sort of, I think this is getting to, C++ gives you a lot of control at sort of a low level, and it's also, the overhead's very low, C++, meaning you can create really tiny programs for, well, if you have a watch or your microwave even, you want that ability to write a really small optimized program for that system. So C++, C, these kind of languages are used in those systems. Yeah.
I have a question. I heard people say like they use C++ because it has classes, but if C has classes, they would be using C.
Yeah.
I
So
that. I didn't get into that deep into C. I didn't know they didn't have classes.
yeah. So for a lot of the folks who've taken systems, right, we've done C, and then a lot of folks I think have also done Java programming, right, where you have classes and can sort of build your objects. So where C++ originated is it was called C with classes, so they sort of added this feature. We can also think of classes and object-oriented programming as sort of a design pattern in a way of how we organize our programs. But that's certainly true, right? It's got other abstractions and paradigms built into it. So maybe folks have done functional programming. You can do that in C++, or object-oriented programming, or just sort of straight procedural programming, or structure. These sort of different paradigms, maybe you've learned in PDP for folks who have taken that, are all available in C++. So it makes it a really sort of big language in this sense. Yeah. Other thoughts or things that you've heard?
Why do you prefer C++ over other object-oriented programming?
For me personally, yeah, that's a good question. One, I always try to use the right tool for the right job. So the ideal application that we're going to be building is something that's performance sensitive. We would want sort of control over some of the libraries are C++ facing. The reality is you can do almost everything in Python, right? It's got a library. Some of it's also expertise and what I think I can sort of teach. Some of it's I think the reality is when I use it in graphics and in game engines and some of these courses, it's very clear why. That's what the industry uses. That's what the job postings are. Software engineering is very big, right? The chances are lots of you are going to go out and do a range of full stack development. Some will do C++, embedded, huge range. I think it's still the right tool for this class. I think what C++ is going to get you in this class that you might not get if we did it in other languages is some of the talk about build systems, how it integrates with Git, some of the sort of analysis and testing tools that sort of originate in C++. I think it's got the right tooling infrastructure, which I think today is just as important as knowing a particular language. Just what's the tooling that's built around it. And getting to see it from the C++ perspective. I think that's going to be really important and hopefully eye-opening and not make it a scary language. No one said scary yet. Any other thoughts? Yeah.
I heard that in modern C++, you don't really have to use raw pointers anymore.
That's true. Yeah. So for folks again who have done systems or just C programming, right? We learn about sort of raw pointers. I'm going to talk about them and refresh you a little bit. There's something called smart pointers, so you don't have to really manage your memory. You can use C++ like you'd use in Java, for instance. And that's sort of the preferred style. Yeah. In the back.
Quick question.
Yep.
Why hasn't the GC been added yet?
So why hasn't garbage collection been added to C++?
I remember Bjorn talked about adding it a while back.
Yeah.
Why do we still have to find it?
Yeah, maybe we've seen the same interview. So Bjorn Strusa, he's I don't forget his exact background if he's Norwegian, but he way back in the 80s he implemented a garbage collection system, so you wouldn't have to manually manage your memory. I think historically why he didn't implement it is it was just too slow at the time, because we're talking like 80s or 90s that he built this system. Then I think some time passed and Java was sort of the right language at the right time in the mid-90s when machines were getting faster and so on, and had some other things built into it. But there's nothing stopping you from building your own system. In fact, Java, the language, is implemented in C++. You just have to implement the garbage collection algorithm. Does anybody know the story about the JavaScript language and how many days it took to develop that language? Was there something?
5
I think it was, I don't know the exact, it was a little bit more than 5, but I think it was either 17's the number, 17 days or 14 days that the backbone of the language that we use on the internet was invented. So sometimes it's just the right tool at the right time. Yeah.
Isn't JavaScript still being updated like pretty much every week?
Yep.
Because it was so slow at first, like it was impossible to read.
Yeah, absolutely. And you have to think, companies like, right, I'm on a Google browser here. They're heavily invested in making things fast and responsive. So, like C++, like JavaScript, all of these languages are constantly being developed as well, which I think is, again, part of the sort of software engineering, language evolution, all these sort of things. So, really, really cool stuff here.
Sorry, last question.
Yeah.
Is that one of the reasons why it's like everybody says it's really hard to master?
Yeah, I think in a sense, a lot of people, the joke with C++ is that nobody knows more than 10% of the language at a given time. Because you just, can't keep it all in your head. And I think that's, myself included. That's probably true of like Python and everything else too. So with that said, we're going to be looking at modern C++. Again, what's sort of relevant today. Yeah, question?
So I heard like C++ is really fast. What would you say? Like, is it fastest or some general idea?
Yeah, I think, if you want to write a fast piece of code, the first thing to do is probably to take the algorithms course, right, and learn what the right algorithm is. There's certain abstractions, I guess, built into the language that might make it slower than, say, C or assembly programming, but it's pretty fast. In fact, I think I have a slide here, another sort of software engineering thing. Maybe I'm stealing my thunder from later, but Facebook, so we're familiar with them. They write in PHP, which is a language that runs on the web, but it's a scripting language, like Python or JavaScript. Those have certain trade-offs about being fast or slow. So what they actually do is they parse or they reread in all their PHP, and then they just translate it to C++ code and run it to get more performance. Or they were doing that for a while. Now they've got other projects and other tools that have just been publicly announced for, like, they do the same, Python to C++. So C++, popular language, number 4, so it's going to be relevant. It's not going away anywhere. This is some rough metric every year or so. They update this, or every month, I think, on this particular index. But so it's super relevant here. Here's my sort of story about HipHop, which is Facebook's tool that translates PHP code into a totally different language. Use a different language, you get different trade-offs. So in this case, you get more performance. And this is true too. I've talked to a couple of friends at Google, and they're spending lots of time rewriting their Python code. I know as much as we love Python, I love it. But at scale, really big, Google scale, they're just translating their Python programs into C++ now because they need more performance. You get better performance, less energy usage, save money, faster, all these sort of trade-offs they had to think about. So with that in mind, the sort of domains, gaming, Netflix, if you go into quantitative finance, you're probably going to want to be using C++ for speed, right, where sort of nanoseconds matter to you. Right? When we're watching Netflix, you want a good sort of smooth experience. So where does the performance come from? I think this is getting to some of our other questions, and that it's a compiled language. So like C, again, for folks who've worked in that, Java as well, in a sense you're recompiling to a lower level. So, what our sort of development cycle is going to look like is writing your code, saving it, recompiling, and getting an executable or machine code that's executed. And that's where we get the speed from. But as mentioned, the speed also comes from the algorithm we chose. So here's some, binary tree implementation. So that could vary as well. So usually the algorithm's most important, and then this sort of language. Or other things you might want to think about, like what does your data actually look like? How does that fit in the actual architecture? Let's see. And then it was mentioned about garbage collector, right? There is no garbage collector, at least by default, unless you build one. So again, you're managing your own resources, and that's another reason why you get a lot of performance. With Java, Python, there's a lot sort of going on behind the scenes for you. So the language has pretty much every feature that you'd want. It's got a really big standard template library. They call the STL. And sometimes we just call it the standard library. So that's the equivalent in a Python or a Java where you're just importing some library or data structure that you need, and we have it. I'll talk a little bit about that in the sense that that's a good thing to probably take advantage of these standard features and spend our time building other infrastructure when these sort of well-tested libraries exist. As was mentioned, it's a very expressive language. So all these things. It can be functional, it can be object-oriented, and so on. Disadvantages, or just jokes to break things up. So here's Bjorn Strusup, the creator here. He says, C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows the whole leg off. So, this goes to some of the things. C++ is a language where you can get segmentation faults and null pointers and these things that we'll have to deal with a little bit. There isn't built-in security, so it can be hard to track bugs sometimes depending on what's going on. So these can be some of the hurdles, right? No language is perfect. Again, this course, as every computer science course in a sense, you want to go in the mindset of just figuring out what are the trade-offs. What am I trading off? What makes this language so fast that makes it impressive to use? What am I losing for that speed? Maybe it's security or something else. All right, so a little bit of wisdom. I got to give you some wisdom here, some gold nuggets. So this is from one of the textbooks. It's recommended. It can be read before, after, or during this course, to be honest with you. It's called The Pragmatic Programmer. It's 20 plus years old at this point, but the wisdom still applies. But their wisdom from this little snippet in chapter 1, actually at the very start of the book, is just trying to be aware of the bigger picture here. So not really worrying about the language or the tools. Just kind of choose the best you can and focus on what you're actually doing. Building some product. What are you trying to engineer? If it's really important that you're building the next Netflix, okay, performance matters. You chose C++. On to the next thing, in a sense. Be aware of that, your dream, in a sense. All right, so with that said, we're approaching about an hour, so I like to do a few breaks. But before we go on break, I want to make available, so if you have your laptops out, now is a good time to do this, the course assignments and labs. So I'll show you where to get those on my website here. So go ahead and try to find my website. And Foundations of Software Engineering. And then you're going to try to find this Required Materials tab. Right in the center there. Everybody a moment to log in or whatever. go ahead and click on that when you get a chance. And then there'll be a bluish button here that you click on. And this is our course monorepo. It's the monolithic repository that's going to have all of our assignments and labs in it, at least during the individual portion of the course. So go ahead and click on that. And it's going to bring you to GitHub Classroom. It may be familiar to some folks, whether in my class or others. It's going to ask you to accept this assignment, and go ahead and accept it. You can use your private GitHub account if you'd like here. I think that'll work just fine. So if you need some time to create one, feel free to do that. And if you're not logged in, there'll be something probably at the top right here asking you to sign in or whatever. But once you do that, go ahead and click Accept Assignment. And it'll give you a URL here in a moment if you refresh this page. And then you can click on the link. And that should bring you to something that looks like this. I'll give everybody a few moments to catch up there, and then I got one more other task for you. Right. Now, if you've made it this far and are staring at our assignment 1 and lab 1, what I want you to do is go ahead and edit the README file here. So you can do that by just clicking on the pencil in the right corner here. And then I just want you to add your name into the repository here. So I know who you are, can distinguish you between your GitHub name and your real name. So you've got your name and then your phonetic pronunciation of your name here. If you could put your real name as it would be on Canvas here, that's useful. And then if you want to put a preferred nickname, you're welcome to do that as well. Just so that's one way I can learn how to address you. And then your pronunciation. So I'll go ahead and do this too. I guess I'd be Michael. Right, and then of course once you've done that, if you scroll to the bottom, it'll ask you to commit your changes, and that'll update the README file. All right, and then we'll talk about the repositories a little bit. I'll give you sort of a workflow, just so you understand what's going on. But then you're all set. Then I'll know who you are compared to your Git name. Alrighty. And then after this, let's go ahead and take a break. It's about 7:04 now. So say till 7:14. Give yourself 10 minutes or so to walk around or cool off or whatever. And then let's meet about 7:14 or so. I'll hang up. I'll be over here if you have other questions. feel free to ask me. Hi there.
So like, yeah,
Yep. Yeah. And then for now, you can just do a little pencil or anything. Perfect. And then, yep, you got it. And then you'll just scroll to the bottom and then commit your changes.
I didn't see when.
So I haven't put them in yet. I'll put them in tomorrow. I think they're going to end up being either Monday, Tuesday, or Thursday in a big block somewhere.
Okay.
That's the plan. You're welcome.
Are they before or after 5?
Yeah, they'll be before. They'll probably be before 5 most of the time.
Okay, because I work full time, so I.
Okay.
Yeah.
So just reach out whenever.
You might. I don't know how to.
Yeah,
Yeah,
I didn't
wanted
recognize
to
you
say-
the first time, and then I
Yeah.
saw the mask. And I was like, I know your voice. So.
Yeah. I'm
good
really
to
glad
see
to be in the class because I don't know, just you're in the. I don't know. I really like your last class, and I trust you to like teach a good class.
We'll do the best we can. That's the plan. Yeah, I want to hear about your summer sometime too. and
No,
see
it
how
ended up being more of just a summer of fun. Like
Yeah.
I was thinking about doing some like an Ethereum type project, but
Yeah.
my sister graduated grad school and my brother got out of the army, so it was like everyone was back, and we're like,
Yeah.
okay, let's
Take advantage.
So-
Yeah, you know. That's good. So if there's a summertime fun, like now's the time to do it. Were you home mostly, or?
Mostly, but I ended up going like my. We had moved. I was in Colorado for the most part
Right.
last year, and so with my brother, and so he got out, and we moved back to North Carolina,
Okay.
and then during the summer, over 4th of July, we met up with our friends from Colorado in Vegas. So
Oh wow, fun.
it wasn't for me, but like it was cool that I went
Yeah.
and then like, oh, I finally been to Vegas, check. So
Yeah, I've only been once, but I want to go again and do some of the. You kind of see the strip and those kind of things, but I need to see like the Hoover Dam and some of the Red Rock stuff.
oh yeah, that stuff does seem neat.
Yeah.
And then he moved to New York City, and so I went and visited him.
Oh wow,
So yeah,
that's a lot of fun. You have a lot of different cities.
but yeah, I don't know.
Oh no, I'm a stretcher.
Stretching.
Cool. I'm just a developer doing work on really old systems.
But yeah, so but I did have a question about the with the one of the slides, the one where Facebook was like translating
Oh yeah.
their PHP.
Yeah.
So does that like at first I was thinking like, okay, you go from something that's untyped to something that's typed, so you have to make a lot of type choices.
Yeah.
But then I'm thinking, well, the like generating bytecode, like you're making those type choices already.
Right.
So are they making basically just a bytecode compiler to C++, or would they make like a, or go directly from the text and then translate?
Yeah, I mean, I think there's a couple layers, right? These are the big questions you have to ask once you start. Like, well, there's a few layers. One, which, what's the type, right? You can sort of just by default say, okay, everything's going to be a long or a float or something, and sort of lazily do it, just get it to work. But yeah, what inference can you do beyond that to figure out, okay, this is used always as a certain value or something? So if you sort of take the lazy approach and just say, okay, everything's going to be a float or a double or something, that works pretty well, but then you do have to start optimizing. So, there's an actual algorithm that C++ uses. So you can just use a type auto, for instance. Right, and that just infers what the type's going to be. That algorithm, I forget what it's called, but there's sort of a famous one that you can prove some value is only going to be within some range sometimes. So you can say, okay, this is definitely a Boolean. Or okay, this one's between, it's never a decimal value. It's never used another function that takes an argument that's not an integer, or these kind of things.
And so if this is like happening, right, or at least internally, if they're building these like I guess,
I work for
transpilers or
Get
whatever,
transpiled,
then,
exactly.
Then why aren't the languages themselves, like, why are then a lot of these interpreted languages still exist? Like,
Yeah.
because it seems like they could just go an extra step, or is it
Yeah.
so much work?
So what happens, because Python does this a little bit. They've got like C Python, which is translates straight to C. What you end up losing usually is, I think, one of two things. One is sort of the debuggability, I guess. Well, you start to lose a few things, like the debuggability, because all of a sudden then you're debugging like different layers of, okay, is this a Python code, is this a C bug, like our transpiler. Sometimes the libraries, if there's dependency, like weird sort of dependencies, that may not translate to, the C equivalent feature, you lose. I guess the other thing is, because I sort of asked myself this question too, it's like, why can't I just use Python and it compiles to something fast? What was that thing? Escaped my mind. But those are a few of the things, just losing the sort of different layers. I guess you also lose the sort of advantage of like PHP. It can just sort of, it's scripting, so it's just always constantly processing when you load a page. Versus if you're going to compile it, you have to go through that edit compile cycle. And sometimes it takes, if it's a big enough project, maybe hours to compile the code. Whereas, this is something that people like about Python. You don't compile, you just hit run again. So then you're balancing sort of developer productivity, and those are just the trade-offs, I guess.
I didn't mean to take up all your time.
No, yeah, I don't know. I like to think about these things too. I don't care.
I'm glad I introduced myself.
Yeah, great to see you in person.
Literally, they have to think but they add on for mail stuff and pretend stuff on top of it. And like,
Alrighty, folks, I'm going to get us back in action here. We're going to pick up with the C++ language. So one of the things I asked folks to do was to watch a video last week. So hopefully most folks got to do that. If you haven't, make sure to watch it again. And I want to, again, sort of give a little bit of a preview, maybe not as in-depth as the actual video, but still a preview of the C++ language. Sort of getting us into the mindset of C++, which we're going to be using. This first few weeks, I want to kind of gently glide us into the language in a sense. And there's a really nice talk here that's also worth watching. I guess more for an instructor, but by Kate Gregory. She's an expert in C++ in this sort of community. She says, stop teaching C. So C++, while it did historically evolve from C, we do want to think about this as sort of the object-oriented language. It's sort of can be used in another way. So just something to keep in mind as we become sort of modern C++ programmers, sort of the best practices of today. So that's how I'm going to approach this class for the most part. So this is your standard sort of hello world in C++. Again, I think in some of the videos there's going to be some, again, repetition. You've heard it from me once. You're going to hear it in slides. I'm going to have you hear it again. But just of what these programs look like. This is your standard C++. You've got your entry point here, your main function, just like Java. Your way to output, cout statement here. This is part of the standard library. So again, if you're speaking in sort of Java, you can think about this as like the java.util.writeLine or whatever the function is, sort of the built-in functions here. So it's coming from the standard library. Sometimes this is pronounced stud, : cout function, and then we're writing out the characters hello through this function here. I actually call it a stream here. That's what these characters are. Okay, and that's how we write hello world in C++. So here's sort of a more heavily annotated version again in the slides if you want to sort of, again, in-depth see what each line's doing. I try to do this the best I can. And I should mention most all the examples that I'm going to show in the slides. I also put them in the code samples folder here. And then for that particular module, so we're in module 1 here. Let's see if we can find our hello program. It is here. And here it is. So there'll be some version of it there. And here's the annotated one as well. So usually I try to write some additional comments in these examples as well. And then of course you can try those out and sort of play with them. Okay, so just having this code is probably not enough for us. Again, C++ is a compiled language. So every time that we're making edits, we have to recompile the code into machine code and then rerun it. Again, so in the videos, hopefully you get a little bit of a sense of how that's working. That's important enough that I just want to go ahead and run through it just to sort of, because this is something that always causes me trouble when I'm like, why isn't it working? I just changed the program. So let me open Vim here. So I'm going to write the hello world program. Again, here's the library, our entry point, a main function. Functions need to return a value, right? Just like in Java here. So C++ is a typed language. We have to say what the type is of everything. Versus if you've used Python or JavaScript, where it just sort of figures out what the type is on the fly. So C++ is statically typed. We're saying this function always returns some integer. Okay, and then from the standard library, we're going to get the cout function and write something custom here. There we are. And then this thing here, the standard endl is just an n line. So sometimes you'll see that there, or you can just use the \n. Okay, so now what I'm going to do is I'm going to write this file. So I'm saving it. Again, folks who are used to me using Vim, I'm saving it here. So the file is saved, and then I need to compile it. Okay, so I'm going to use G++ or Clang++. Let's prefer G++ today. Hello, the file that I'm compiling, what I want to output it as, and the name of that file it's going to be output as. No errors. Prog here, and then of course our message. So if I make any changes here, like say if I do that, but again if I don't save the file and I run it, no changes, right? So that's going to be our sort of edit, compile cycle, recompiling all the time. So this time I'm going to make sure I save, recompile, rerun, and you get the changes. Okay, so that's part of the deal here. Sounds like a simple enough thing now, but we're going to later talk about how to sort of integrate this as part of our build system, and once our projects start getting bigger, how to do this in a smart way. So if I didn't make a change to this file, I don't need to recompile it all the time. Okay, and we've got some automated ways to do that with C++. All right, so here's just a little bit about the flags here. So again, this is our compiler. Something that I didn't add is, again, we're going to be using modern C++. So we want to use a modern version. So I'll add another flag here. And let me go ahead and just do this here. So the language standard here, let's use C++ from 2011. And for the most part, in this course we want to be somewhat modern, so 17 or even 20. 20 I guess isn't supported. 17 it is. But this is sort of a newer version that's been developed, and that'll give us access to new features in the language. Okay. All right. So that's what's going on there. And as mentioned, the compilation process. So I'll follow up a little bit after this lecture with just to sort of, please watch those other videos so I can go through this a little bit quicker for folks who have already done that activity. But again, this is just the compilation process. This will look very familiar for folks who have done systems with me, where we go in depth about how a compiler works as well. Okay, so again, our takeaways, C++ is a compiled language. That's why we're using it. In this compilation process, this is where we really get a lot of the speed from. So this idea that we're compiling into machine code that's going to execute one line at a time that our hardware understands, that's why we're faster than Python, which is literally reading the string almost every time and trying to understand what the code is doing. Folks, again, coming from a Java world, understand that it's sort of a hybrid in between there, where it's sort of just-in-time compiled, right? Where you get some sort of bytecode or machine-looking language that might eventually get compiled. So anyway, that's where you get these sort of performance from. All right. So other C++ things, sort of language things to keep an eye on. Namespaces. Again, this is sort of the equivalent to in Java when you've got all of your sort of packages that you import, and again you have like a java.util. Whatever. In C++, we can just work in the standard namespace if you don't want to type everything out. So you don't have to type out that std : every time. It'll just look in the standard library to see if that function exists. Sometimes you'll see this. I like to be explicit and always put where this code's coming from. That's sort of a best practice for software, in my opinion. All right. So C++ has many different data types, all the standards, again, that you would see in like a Java, but as mentioned, we do have to be explicit, and it's a typed language. There's going to be other common types like string as well that come from the standard library, and likely we'll also talk about some single instruction multiple data types that give us parallelism. Again, another great use case of C++. So how to get performance or parallelism. Okay. So here's what some of the built-in types look like. And again, just sort of slowly putting us in this C++ programmer mindset. Often we care about how big our data is in terms of bytes. So there's ways to sort of query that where we figure out the size of the data type. And sometimes we want to be really, really explicit about what the size is. So there are yet more data types where we say we want an integer that's unsigned, but it's 8 bits or 16 bits exactly. So C++, again, low level, sort of powerful language giving us this sort of control of our data. Again, that's where we're getting this performance from, saying we want exactly this many bytes and we know we'll need no more. Right? If I'm just storing somebody's age, that's probably between 0 and 255, most likely. All right, so here's sort of another hello world using some of these primitives here. Now, one of the dangers that can come up when programming is from using variables and what we call, state changes or the immutability of our data types. So one way we can help make our programs more secure are by labeling things const, which says this data is not ever going to change. It's immutable. It's unchangeable. So if we're storing the value pi, for instance, it's not going to change, hopefully. So 3.1415, whatever, 26 something. So again, a good practice if you know some data is not going to change or you don't want it to change. There's actually a few uses of const as well to enforce this. And this is one of the, this is a subtle thing right now, but when I was sort of alluding to the example of why developers at Google are changing all their Python code to C++, it is for some of these little programming features that enforce what the state is of the program and makes them more debuggable in this sense. So we call this const correctness. All right, C++ has arrays, so just like C, just like Java, should look something like this, where we can say, hey, we just want 5 integers, and they're going to be contiguously lined up here, so 0, 1, 2, 3, 4, and so on. But again, we like that standard library here. So here you'll again see same array, but it's wrapped up, so it's its own container. So here we're using some encapsulation and sort of abstracting an array. So we're saying, yeah, it's going to be 5. It's going to be integers, and then we can have some methods, or in C++ we call member functions, that act on this array. So that tell us what the size is, or what the first element are, and so on. Okay, so we can get a little bit more power, and again, this is what makes us modern C++ programmers. We're saying, yucky, look at this array, this isn't powerful. Let's add some more power to it, wrap it up, add some abstraction. Okay, and then we can switch those abstractions out easier, or the actual implementation, right? But to the user of this, it doesn't really matter. They just know they've got an array with 5 integers here. So we're good to go. All right. So we'll talk about some of these containers, but here are just some of the things you can do with that array class or that data type that is part of this standard versus just the sort of naked array, which is just 5 of something. Loops, we got some loops here. So for loops should be familiar. We've also got range-based loops as well, so another way to iterate or look through a data collection. So we'll see some things that look like this. Again, these are new things that will make us modern C++ programmers. And again, it's subtle, but often this describes the intent of the code. So it's saying, okay, for something called I, we'll get to what is this weird ampersand thing here. But through our array, this is at least giving us the intent that, well, it's a for loop, and we definitely want to look through everything. Versus, perhaps this example where there's room for programmer error here. This one looks like the same thing, I guess, where we want to look through the whole size, but if this was anything else, did we intend to look through half of it? Did we want to do array.size divided by 2, or what was it? Versus this construct, which means there's only one path here. You just want to look through everything. So again, we're using the language to enforce some good software and sort of show the programmer's intent here. And of course, we should write comments. This is a bad comment, though. Iterate through our array. well, how? You know, everything, or just half of it? We don't know. All right, while loops, same thing, print forever. Yes, yeah.
Stupid question. Do you have a comment about like what this part of code does, or would you rather comment explaining why are you doing that?
Not a bad question at all. Yeah, there's no bad questions. So the question's about like comments, right? Because there's different schools of thoughts, and I tend to be on the side where, if I'm reading a Stack Overflow and somebody will be like reviewing their code, and I don't know how to properly say this, but some really like macho programmer will come over and be like, of course I understand what that does. Why did you write a comment? I can see x equals whatever. I would say always go for the side of safety for your comments. The why is usually more important. So why are you doing something? Why am I iterating through this array? We can parse this pretty easily. So a better comment would be presenting to the user all of their data at the user interface when they start the program, or something like that, right? It's saying why we're doing it. Then I think the how can come with that. So I would say both. Opt for more comments than less. I don't think anybody will be upset with you if you do more. I think there is sort of this, sometimes you'll see where they say, the code should speak for itself. And again, maybe there'll be different opinions, but yeah.
I don't like that idea because I don't know, but your coding might be self-explanatory for you, but not for others.
Exactly, yeah.
Especially, I don't want to spend minutes to really understand because it's kind of a waste of time.
Yeah, I don't think anybody would really get upset if you wrote too many comments versus 0, right? And even you yourself, as you're rereading your code, it can be a great way to sort of teach yourself what's going on as well by being able to, if you can explain even line by line, I think it's fine. So I would urge that. That's sort of what I've used in practice, and so far I haven't gotten any pushback. Sometimes, I might want to look. If I ever try to be cool in this class and show something fancy and there's no comments, call me out on it. So I should be commenting. Sometimes I got to fit everything in the slide, but there should be annotations. Always. Yeah. All right. So we've got functions in C++, just like everything. So here's a function here, square. We have to declare them before we use them. So this function has been declared as well as defined. So what is it doing? The body of the code here as well. So you could alternatively do this. So I'll use these terms, declaration and definition, sometimes. But that's what it means here. So I've declared, if I'm reading this program top to bottom, okay, there's something called square. It takes in an integer x here. So we know it exists. And then later on in our program, we'll say, okay, we said it exists here. We aren't going to complain or say this function's undefined. But you have to define it somewhere else. What does it, or how does it actually compute the square? All right. And there are little tricks, again, with C++. So again, we're learning language. So again, if we hold on to this square function for just a moment, in C++, beyond just saying, well, this returns an integer here, we can put this additional qualifier here. It's called constexpr, which means sort of a constant expression. So it's something that we can evaluate at compile time. So while we're compiling our program, the C++ compiler, again, this is part of the why C++ and sort of the tooling part of this class, like it's the motivation. It's like, well, if I'm just computing the square of 5, I'm pretty sure that's not going to change if I'm just evaluating 5 times 5 every time. So compute what this is going to be while you're compiling the code. And then when you're running the code, just swap in and just make this 25 every time. Don't bother to call a function and do this all this other work. Just put 25 in here. Right? And C++ can be smart enough to figure that out in the actual tooling. So you can sort of annotate your code in this way. This is sort of the very hot thing to do right now, because then you get more performance. It's less work you have to do, again, while your program's running. So who thinks this is good for performance? Oh, I just told you it should be, so. But there's a trade-off, though. Yeah, comment.
Does that mean, like, you couldn't take user input into a const-expr function? Like, it has to be within the program itself?
Yeah, so it's going to request or attempt. So it's going to spend extra time when you're compiling your program to say, okay, can I figure out what this is with 100% certainty? But as you said, if this was just square of x here, I'm asking what x is, it's not going to replace it with anything. In a sense, yeah. If it doesn't know, then it'll just run regularly. But if it can know, then it will do that substitution.
So you can, like, put it, and it's not going to error out if you, like, were taking user input.
Correct. Yeah.
Okay.
Yep. But again, yeah, the trade-off is it's going to spend extra time when you're compiling to say, whoa, can I figure this out? I don't know. And it's going to look through all your code. And so that's the trade-off. So may slow down your compilation time, but otherwise good for runtime performance when your program's actually running. Okay. So in C++ is a language. Again, what makes it sort of interesting is we're thinking about what happens at compile time. How can we improve performance? What bugs can we detect so that when the program's actually running, we get better performance and fewer bugs than when the actual user is using our software. So there's other things like this, like static assert. So here's just another example where you can claim that something must be true before your program runs. Like, how big is the data type? This is sort of a common use case of it. So if I'm on a really, really new system here, I want to know that integers are 8 bytes for some reason. Or if I'm programming on a microwave, maybe it's integers are represented by a different amount of bytes. So you can sort of make these assertions here. Okay. And we can do the same thing with casting our data. What's casting mean? I guess this might be a new term, especially if you're coming straight from Python. If I want to cast something, yeah. Yep, exactly. So it's saying, I want to treat, I'm going to grab a marker here. So if I've got some integer here, actually stop myself for the recording. So maybe I create an integer here and I say it's 7, but I really want to treat it as a float somewhere else. I can sort of make this treat it as 7.0 for some reason to get extra efficiency or sort of adapt how this variable works. Okay, so we can do that same thing and handle this at compile time. All right, so we've got a bunch of data. Thinking a little bit about how we access that data. Again, C++, it's a curly brace language, same thing as Java, so just kind of paying attention to our indentation. But what this means is scope, so sort of how long is this variable alive? This int x here, well, between lines 7 and 9, between the curly braces. Okay. So something that you learned in your first programming class, but I like to think about this as sort of the liveness, maybe a term you haven't learned, but how long is this variable alive? Okay, and in C++, it determines, well, automatically this x is going to be alive until line 9, this one, till 13, and then you can redeclare it and so forth. Now, where I'm going with this is with objects, so thinking about them. So in C++, when we create classes, so kind of thinking about your Java. In Java, you have a constructor that's some method or member function that we call in C++ that's automatically called when a piece of or an object's created. But we also have destructors, so some piece of code that's automatically called when an object goes out of scope or is no longer alive. So we have to define both of those in C++. Okay, so in this example here, you can see where the curly braces are. I just create some object here. So it's its local scope is here between lines 15 and 17, and once we hit line 17, the destructor is automatically called, which just prints out created and destroyed respectively for the constructor or destructor. Okay, so there's a couple more ideas on this slide as well. So classes and objects, which should be, again, familiar from Java, and then stack allocated data, maybe familiar from systems. Okay, so kind of run through this. Classes, I think we're familiar with, again, attributes, the data that's associated with them, and the behaviors, which are the methods is the Java term, but I'm going to start sticking to member functions. That's what we call it in C++. That's the behavior, how we actually do the work. Okay, so here's an example here, and just sort of labeling everything. Okay, so getting into something that's a little bit different about C++, and this is thinking about the sort of physical structure of our actual programs, meaning what files are there, what directories. In C++, we actually separate out the interfaces into a separate file versus the actual implementations. So in C++, we have a .h file, which is our interface, and the implementation goes in a .cpp file, a C++ file. Yes? Yeah.
Sorry, my first question is why? Is it for debugging purposes?
Yeah, so couple reasons. One is it sort of follows C, I guess. The other reason is mostly for the linking stage. So we're going to glue two pieces of code together in a library. You at least want to know what's in the header file that says, hey, I promise this function exists, and these associated member functions. And then later you can link in the actual implementation that does the work. So maybe I have a proprietary piece of software, I can give you the header, but I don't want to expose my private algorithm that I've implemented here. So we have this sort of separation in that way. That's one of the reasons, or at least a use case. In some ways, I like this. This is kind of clean. We'll talk about reading code. We're going to look at some larger code bases, but you can kind of just look at the interface here in the .h and be like, oh, okay, this is sort of accessible. This is the functions available, the classes, without having to see that with all the implementation details as well. So it can work to our advantage. I actually like that separation for that reason. All right, so just to show that sort of explicitly, here's the header file on the top right, where I've just got class, what's available, and so on. In the bottom, the C++ file. Okay, and for folks who watch the video about the compilation stuff and the preprocessor, just to be reminded, you'll see these little hash marks here, the pound symbol or the hashtag. If and if, what is it? Oh, I thought somebody had the actual, I just call it the pound symbol, I guess. But anything with the pound symbol in front of it means it's running with the preprocessor. So it's saying, if not defined, game object _h, define it, and then tell us about this. If we don't include these header guards, which is what we call them, then if we include this file, gameObject.h, a bunch of times, it'll say duplicate entry here. Okay, so just giving you a little preface of why those things are there. All right, so again, here's just sort of a full project and compiling things. So here's the header file, top left, implementation on the bottom left, the main program here. The main program is including the header file here that says, oh, okay, game object's available. Here's your class here. I'm going to include it just one time. And then once it's been included, then you can start using this actual game object class. And then when you compile the code, Clang++, standard C++ 2011, and then each of the C++ files. The actual implementation down the bottom left, and then our main.cpp file. Okay? And as you add more C++ files, you would add them accordingly here. Okay, so that'll look, again, sort of similar to Java if you've done this on command line. Yeah.
Do we have separate header files for all the classes, or do we have like one header file for all the classes in a particular project?
Yeah, typical style question about one header file per one C++ file, and that is the typical recommendation. Yep. That would be a good programming practice. Yeah.
Once you have like a large, very large project, that you highly time you to have a lot of CVP files, and you have like TXT where you call them one. I don't know. I can imagine like having them like 50.
Yep.
or more.
Absolutely. Yeah. So we're going to have some questions about what happens when I have 50 or 1,000, millions or whatever these files. Right. You can sort of use a wildcard star.cpp. But we'll actually have a build system that builds each of these files. And not just the files, all of them one at a time, but, for example, only the ones that have changed. So that'll save time there. There's a few different tools. If you've used Make, I think we briefly introduced it in my systems class. In Java, maybe you've used a range of Gradle, Maven, Ant. I don't. There's just a million of them. I don't know, but that would be the sort of goal. All right, pop quiz C++, because I know a bunch of people have used it here. So C++ has structs. What's the difference between a class and a struct, the keyword?
In a struct, everything is public by default, and in a class, it's private by default.
Yep, exactly. So it just has to do with is this constructor publicly or privately available? And so going back to your Java knowledge, C++ has the same public, protected, and private accessibility levels. And that's it. Stylistically, folks will use structs for just collections of data, usually primitive types, and then classes for everything else, like you would in Java. So that's a stylistic thing. So struct's usually a piece of data type. Yeah.
It seems like with object-oriented programming languages that there's push away from having data-oriented, or primitive types, like you're saying. So it seems like anytime you make a primitive type, you might think, if you have C++, why aren't I just putting this in a class and then putting some sort of methods around it? So is there an example you have of when you use just a data point or just data?
Yeah. So I think the question's about abstraction and figuring out. C++ sort of wants us to have a standard array class and all these things, sort of wrapping everything up into a class. Versus when do I want just a plain old structure type here? So let me go here, for example. Let me know if that's the question. So when do I want to just do something like this? This is sort of like the classic example here of a student, your age, your ID, whatever. This is sort of the plain old type where you want some composite or just aggregate data, I guess. And you don't want to really do anything interesting with it.
I guess my question is more, well, if you have that, wouldn't you obviously be doing something interesting with it to the point where you say, oh, you want to update age or you want to do something, so why would you ever have a struct? Because you're inevitably going to have.
Yeah, maybe. And it doesn't ban you or limit you. I think I'd have to think a little bit. Think about a use case. I'm trying to think of something that I've done recently. I mean, the most common thing, I guess, I think I'll have an example here, is in graphics you'll have a lot of things where you have some mathematical thing we call them a vector, and just say, okay, this is going to be a vector of 3 floats, and you're going to have sort of an x, y, and z dimension. So you tend to see a lot of these sort of types pop up.
Oh, yeah.
But there's nothing that's stopping me from saying, I go in here and then, okay, I want to compute, what's the magnitude, or start adding, what happens if I multiply 2 of these or add 2. So, I think a code's gonna evolve. So, once you give somebody the tools, they'll probably start adding or find something interesting to add here. But this is what I tend to do. A lot of these little like types like this.
Yeah, that makes sense.
Let's see here. All right, so yeah, we generally like classes. I guess that gets it. Or this idea of object-oriented programming, right? Having all of our data with the behaviors together. So we will talk about some things like inheritance, this idea of building things that are of this type. So this sort of is a relationship versus a has a relationship. So a circle is a shape, a rectangle is a shape. Triangle is a shape, and it should be able to do all the things or act as a shape here. C++ lets you do something a little bit wild too, called multiple inheritance. So I'll leave this up here and sort of give you guys a question. What's the problem here? So if we've got class A, and I'll give everybody a few moments to study this. And class B is a class A, and class C also is. And then class D is a type of B, it is a C. Let me let everybody think about it, then I'll take a volunteer. What do folks think? I mean, is this a problem? Yeah.
So Class B and Class C could implement parts of Class A differently, and then when Class D goes to call it, it would have to make the decision on which one to use.
Yeah. Which one do you think it should use, too?
I don't know if there is a right answer.
Yeah. Sometimes it depends on the compiler. Sometimes it just chooses randomly, which, anytime our compilers are just choosing what the program should do, that's probably bad. Right? That's how every sci-fi movie, goes array. And it's also just kind of complicated to look at, but you've got the exact problem here, right? Class B implements some member function, Class C, the same thing with the same name, which is legal, and Class D just picks one. Maybe at random. So this has a name here. It's an anti-pattern, we would call it. So you learn about design patterns and anti-patterns. This is the deadly diamond inheritance pattern. This forms sort of a diamond. This would be a simple form of it, but again, as you can imagine, big code bases, you could have sort of multiple diamonds and many layers associated here. So if you're debugging this, it's problematic. Yes, in the back.
So the dynamic dispatch of class D is random.
Yeah, so the dynamic dispatch meaning, right, if class D inherits from B and C, and let's sort of do this just to keep everybody with us on names. So let's say class B and C implement some member function called sing, something like that. And then class D could create a new object and implement that sing function, or you just call it. It's going to either pick this one or this one randomly at runtime. That's the dynamic dispatch. Is it implementing the one that's B's song or C's song? Random, yeah. So it's whoever made the compiler says, okay, maybe it's the first one. Behind the scenes, there's sort of a data structure, right, keeping track of where the pointers are. And it's just probably going to pick the first one that it finds. Yes?
I guess, it's bad practice which always sort of avoid is like design, right? But if you happen to say this and then think, how do you solve this? Because it can be a nightmare to restructure the code because it has all these inheritance.
Yeah.
How would you
Yeah. This is a good question. Something to be thinking about. I have to remember, you guys are asking great questions, if we're going to steal my thunder later or not. Either for Lab 1 or Lab 2, but I'm going to ask you to refactor something that basically has inheritance. It's improperly used. What do folks remember from, I guess, what's your other tool in object-oriented design? You have inheritance and composition, right? So you sort of have, that's where your trade-off sort of is. So you can say, well, maybe I can refactor this to say, well, class D, maybe it wants to do some of these things. And if I really know, I'm going to force the program every time that they create this object to also, figure out what that is a relationship and compose it with B or C if it should act a different way. There's, I would say, limited use cases of multiple inheritance where it goes well. I've actually got one or two, just because someone's asked me, I've thought about it, of where you might want something like this, but you have to make sure that class B and class C are sort of totally different and have very well-defined responsibilities in those classes. And yeah, it just becomes a headache to, you have to have the comments, again, going back to that, about why you really wanted to do this and why it was a good idea. Java, for example, likely you did not talk about this because by default it doesn't allow you to have multiple inheritance. You can still do it if you try really hard with your interfaces, but in general, Java protects you again. C++ doesn't. Yeah.
Does C++ have a design pattern similar to Java's interfaces?
Yes. Yep. So if you want it, so interface just being they just call it an abstract class, I guess. I don't think I have anything here, but you define them as pure, basically, a pure class. There's a way to do that. And it's close. You can get it to almost be an interface.
But like syntactically, you would, if you say you wanted to do something like in Java, you would have like an extends class and then implements in interface. If you wanted to do something like in C++, would you have to do like extends class and then also extends like your abstract class?
Yeah, in a sense. So what you'll do is you'll make these, like class A would be, we call it a pure, all of the member functions would be pure functions, and it forces you to implement them every time. So we will look at that. Yeah. There's always a way, because there must be, right? Because I told you Java's implemented in C++, so. Or at least most of the compilers are. So. All right, so we don't like that. All right, so these same things, polymorphism and so on, are available. This has different names. So the dynamic dispatch, which is the term for sort of figuring out which function do I call at runtime. Right, and you sort of, there's sort of the polymorphism in that term, and then polymorphism, as you might have also learned it, is the same function name with different parameters or different types also available. Okay, so this version. Okay, so square functions that return floats or integers. Okay, so with that said, again, we've been going, let's go a little bit more, then we'll take another break, and then we'll power through to the end. Just to finish up this idea, so about classes and objects, and then getting a little bit into memory management, because that's what we've got to do with C++, manage our own memory. All right, and again, taking us back to systems and thinking about some of these things, as well as Java, when you use something like new, we've got stack allocated data as well as heap allocated data. So stack's the stuff that's managed for us. You just create a variable and then it goes away. So again, in our example here, if I just have a curly brace, I create some variable here, like this. Right? This is allocated just on the stack here, and it'll go away by the time it hits line 9. Okay, and that's versus something else in C++, where we say with the new keyword here. So we have a new piece of data, one integer here. This data will live forever until we explicitly delete it. Okay, and we should do that probably as soon as we're done with it. So we type out delete. Okay, so this is on the heap, what we call it, and this is on the stack. Okay, so memory management is the best and the worst part of C++. in a sense. Yeah, question.
Are they actually like physically different parts or registers or anything?
Yeah, well, as far as registers, maybe I need to think about that, but as far as where they're being allocated in the actual process that's running, the stack is a fixed size, so it can only get so big and so small per process, but the heap is, you can sort of think about it as, somewhere that's going to live a long time, just some other piece of memory, like your hard drive, for instance, that could just live there.
So it's not only like a concept, like physically different.
But it is an abstraction that, at the operating system level, each process that's running sort of understands stack versus heap. And stack literally is, like the stack of dishes that you're, pulling on top the whatever's on the top and sort of deleting it in that way.
So does the new keyword like allocate memory during the compile time or the runtime?
During runtime. Yeah, actually, that's a great, maybe that's the proper question I should be asking is, why do we need to have this sort of distinguishment of stack versus heap, I guess? Why would I want to say, okay, I need to create this data when the program's running? And I'm saying, hey, quick, while my program's running, I need some new data here. I've just decided. I heard something. I guess. Yeah, in the back.
So if you have a data that is being used, you want that on the heap and not on the stack. It's going to pop up.
Yeah. So again, maybe thinking about lifetime, maybe about what data are we actually using. So let's make this a little bit more of a concrete example. Let's name this something better than data. How about downloaded data or something, right? And we don't really know until the program's running how much space to allocate for that. So you ask while the program's running, we say, oh, okay, you're downloading, your favorite song or whatever, so you're going to need exactly this many bytes. Versus, you're downloading or streaming a movie, which is going to need a bigger amount of space. So it allows you to do that at runtime. Versus something that's fixed here, which we say, well, in integer, x equals 7, that's always going to be 4 bytes. So we know that. So when we create our program, when we compile it, we're just going to say, hey, reserve 4 bytes, make sure to do that at this point in time, and we're good to go. Okay. And then, since this is C++, we have to, again, explicitly delete it. Java figures it out for us with its garbage collector. Python as well, behind the scenes. All right, so just some basics again on memory, thinking about how much space different data types take. And this data also has to live somewhere. It has to have some memory address. Okay, so we have to keep track of that. How do we figure out what that address is? Well, this is one of the nice things. In C++, we can always query it with the ampersand. So ampersand, you can think of the address of, if you want. Same thing as in C. I like to actually think of it like a function. It just doesn't have the parentheses that you normally use with a function. Actually, you can put ampersand parentheses around x if that's helpful for you. It's returning the address. Okay, where in memory does this thing live? Okay, that's the other C++ things to keep in mind. Here's an example for you folks to figure out what is the value of x at line 11. So just sort of walking through and getting used to reading and some semantics here. Here's the entry point of our program, x equals 42. We call this function here, passing in x. Set value takes in an integer, sets that integer to 9999, and give everybody a moment to think about what is x going to be here. If you've done this experiment in C, or remember it, because I've done the same experiment, lock in your answers, and then I'll take a answer or a question? Answer, yeah. 42, let's see. 42 it is. So a little bit of a strange language. Depending on what language you're using, this answer can vary. But what's happening here is in C++ is whenever we pass in this variable here, x, it's actually just making a copy of this and passing that copy in. So we call this pass by value and saying, okay, what's the actual value? Pass in a copy of that. And when I get into line 5 here, right, when I've called this set value, it's just passing in a copy of this x here. So it's not the actual x that we saw at line 9, right? This lives in a different place in memory. It's changing that copy, and then it goes out of scope here. Well, when we print things out, we just say, well, what is x? Well, nothing's changed with it. We've changed the copy of x, but not x itself. Okay, questions on this? Yeah, in the back.
What if you pass the address?
Oh, okay. Well, let's see. All right, give everybody a chance to think about this. There's a nice suggestion here. So what if I pass the address, right? Or I guess there's a few ways I can do this. Actually, let's just do this. This one's worth doing live. Okay, so let's do our pass by value. Let me just rotate this a little bit. Okay, so this is going to be our little hello program. And what I'm doing here, anytime you have questions about these, is always to just run a little experiment. So I always like to create these little experiments like this. Set value. We were taking in just something like this. A equals 999. X equals 42. And then we call set value. And so are you suggesting to put the ampersand here? All right. So we're saying, hey, pass in the address of this thing here. And let's print it out. X is, and let's give a end line here. Okay. And I made some changes. I got to recompile this, our hello program. Oops, let's see what happened here. Error, invalid conversion. Okay. What happened here? Set value. So it's trying to give us some hints here. Invalid conversion. We haven't learned about this thing, or maybe we remember this from a while ago. Looks like I have to make it. Should I make the little fix? Yeah. So we haven't learned about pointers yet, or we're just re-remembering them. And then I'm going to modify your suggestion one more way in a second. So we actually, if we want to pass in an address of x, that's sort of a different thing, like just passing in a memory address as a type. And we have a way to take types of different things, which are pointers. So you can store the address of something that is of an integer type by appending this asterisk to it. So let's try this. Okay. Oops, and now this says invalid conversion. Well, this thing here, and let's see what do we remember from C. Since this type is of a pointer here, and let me relabel this as pointer. Sometimes I like to put a little prefix in front of a variable name just to help me remember. So pointer A, we actually have to dereference it. And then, so that's what this error message is saying. So pointers hold the address of something, and when we put the star in front of it, or the asterisk, we're saying, okay, look inside of that box where the actual value is and change it. Okay, it compiles now. Do we get 42? I'll let you just think about it. I kind of lock in there, I guess. And as well, if you're at this point and saying, whoa, lots of stars and stuff, I remember that from systems and it was scary. That's what this first week or two is about, refreshing some of these things. So if I run this, x is 99999. We did it. So because, and this is getting back to the suggestion, we're passing in the address of this thing where it lives. At this point, we don't really care. Is it stack memory? Is it heap memory? It doesn't matter. We're saying, hey, wherever it does live, give us that address, and store it in this thing called a pointer, and then change it by dereferencing it. And dereferencing you can think of as following that address that you're pointing to, and then grabbing the actual value. Questions on this? All right, and then I'm going to change it up one more way. So this is a very C programming type of thing to do. This is what we would do in C, right? This idea of we want to pass variables or some quantity into a function and then modify its state for what it does. So C++ programmers came in later on and said, hey, this is a pretty useful idea. So we're actually going to give this a sort of a shorthand here. And before I do this, actually, what's the danger really of this right here? This parameter. When I pass pointers, actually, what's the general danger with pointers that folks remember? And what was that? Dangling pointers, which is a pointer that points to invalid data. Yeah, points to nothing. Null pointer. You get these in sort of different languages. In Java, you get it as like a null pointer dereferencer. But yeah, something that points to nothing, right? So for example, let's do that here. If I just pass in like 0 or something, I think this will crash us. Maybe it'll warn us. Segmentation fault. Oh no. Yeah. What is 0? Okay, we're trying to dereference this memory address 0 or something and saying no, you're not allowed to do that. So C++ programmers came in and said, wow, this is like the worst thing about programming. We're fighting all these segmentation faults, all these null pointers, and wrestling with the dreaded segmentation fault. So instead, they do this thing where we say, okay, we're going to create a different sort of type here, int with the ampersand. This is called a reference type. So we're going to refer to something. And I'm just going to rename this so you sort of learn thing. Ref would be sort of a fine name, but reference. Okay, let's get rid of all the stars. We don't need all this confusion yet. Okay, and let's try this. This is the next example on the slide. I'm going to compile it and catch my errors here. There we go. Let's see if it compiles. It compiles. And not knowing anything, I guess, about C++ at this point, about this new ID, but a reference, but maybe you've heard it in Java's or Python sort of has this pass by reference idea. But what do you think X is going to be at this point? I'll just let you think about it, and then I'm going to hit enter. Think about it. You got 2 guesses, I guess, or 3. It could be segmentation. But this time it is indeed 9999. It's changed. So what's different this time? C++ not only has pass by value, where we always say, hey, just copy the thing, make a copy by default, but it has pass by reference, which is basically saying, well, reference, I want to refer to something. Right? You can refer to me as Mike, you can refer to me as Michael, you can refer to me as Professor if you want. We don't have to be that formal, but right, those are different ways you can refer to me, different aliases. So essentially, when you put the little ampersand here, it's an alias or saying, hey, this thing that I want to pass in here, just refer to it as reference, and no matter how you change it, just change it. Okay. So it's pretty much the exact same thing we're doing with the pointers. Now, why is this safer? Why is this better? Why is this going to make us better programmers? Well, let's try that same experiment where we just pass in like 0 or something wild in here. It's not going to let us pass in null data, basically. So again, maybe this is too much in the weeds of things, but stylistically, we're using our language, using our tool to build safer software. Yeah, question?
So everything by default is value?
Yes. Yep.
every
Yep. And then we pass by reference if we do think that we want to change something in a function. And if we must, then we pass in a pointer. And I'll explain the use cases for it. I think I have a slide here. Not important that you remember all these details, but important that you're sort of thinking about some of the terms. Pass by value, pass by reference. When you're debugging 10 weeks from now, you're going to be like, oh, yeah, you're not going to even remember this right here. But alrighty. So that's exactly the next series of exercise here. Pass by reference so you can review. All right. So that's this thing. You can put the ampersand with next to the name or next to the type. I tend to prefer next to the type these days. All right. So let's pause there. That's a good, we've been going at it for an hour here. Till about 8:25, and then we're going to zoom into the finish and talk about our lab and assignments, and then move on from there. So give yourself about 9 minutes or so. Pardon?
Do you mind if I do an introduction now instead of office?
Oh, sure, yeah.
My name's Blake Booth. I work at BNY Mellon Bank.
Oh, okay.
I work as a software engineer.
Very cool.
I've been there for like 2 or 3 years. I did a co-op there, internship. I did the Check Campus program, and I worked there and got to meet the developer.
Very cool.
Had a lot of odd jobs while I was in college.
Yeah.
A lot of restaurant work.
Yeah.
Yeah.
Was college here at Northeastern too, or
No. I went to this really small and crappy school in the country.
What was it?
It's called Robert Morris University in Pennsylvania.
Okay.
Yeah, I learned
Robert Morris,
I
you said, or?
What's it?
Robert Morris? Sure.
Yeah.
Okay.
Yeah. So this school I went to is it's like 4 buildings.
Yep.
It's like I know it's so small. I learned they didn't have like a lot of other languages like C++ or Java they're using, so it's really old school. So I learned like assembly, COBOL, Fortran, and
Interesting. Wow. Okay.
and like mainframes. So I work on mainframes on a daily basis now.
Surprisingly, it's still an active area.
I know.
And stuff, so.
I am the youngest person.
Well, you've got job security, so.
I always like look up to people and they're like, "You're the youngest person. You can get promoted to management." I'm like, I don't want to work at a bank. I was thinking work at something more fun or something else.
Yeah. Interesting.
It's very depressing working at a bank.
Well, that's why you're gonna learn some C++ or whatever.
Yeah.
The reality is any work experience the first few years
I
will be
know.
learning something.
Yeah.
But in our field, as you find out, folks switch every 2-ish years. It seems 2 to 4.
Well, yeah, I was saying by 3 years, it makes no sense to stay at this company. I have said that to them many times because what happens is you are usually pushed into a position where you can't go up or down or do anything.
Mhm.
So, and then also that you reach a cap of where you're at 100K, the company stops putting contributions into your 401K even.
Oh,
So
wow.
you have no profit sharing opportunities. You have no it literally doesn't make any sense for you to stay at this company.
Yeah, they're not given the right incentive structure.
Yeah, no, there's no incentives either at bank. This is typical for banks.
Interesting.
Typical structure, which it makes no sense.
Huh.
Also, the 401K is not safe harbor, so you have to wait 3 years to decline in 401K.
Oh wow. Okay.
So it's
Interesting.
really doesn't make any sense to stay there.
Yeah. How do they get away with that? I guess maybe it's a more balanced lifestyle, or.
They try to make it more balanced lifestyle, but it's something like Goldman Sachs that you read in the news maybe they work you to death.
Right.
What occurs usually is that you're talking to business people, not really tech people.
I see.
Not even people who understand their own processes.
Mhm.
It's because everything is more by these cycles. They're not on demand.
Mhm.
So there's everything's about job cycle. Everything's about job scheduling, job cycle.
Interesting.
So it's really not a great process setup that they set up infrastructurally.
Uh-huh.
So imagine you get these programs right. They write them so COBOL has a incredibly low runtime because you're dealing straight up with the compiler process.
Right.
So you have all these jobs that run, and a lot of places use vSAN files, which are memory files, so they can go back to your pointers and stuff.
Yep.
They don't have them set up in databases instead.
Huh.
So what happens is you have all these jobs that are running, you're going to run into these file contentions all the time. So it's like a mess every day because
Wow.
I'm the on-call person 3 out of the 5 days of the week.
Wow.
So I get like all these Cabal engineers. I'm like, oh my god, why? So yeah, no, that's basically what I do on a daily basis. Wasn't
Interesting.
no, I saw you work with PlayStation. I was like, that's like my 12-year-old dream.
Yeah, I mean, it was mine. I mean, and it was super cool. I worked as a compiler engineer.
Mm.
I mean, I'm always trying to figure out. I think I would go on a sabbatical or something. I'd love to go back.
Mm.
The entertainment industry can be a little bit grueling. There's crunch time and some of that stuff.
Yeah,
Depends on your teams and stuff.
I always refer to Cyberpunk as my like.
Yeah.
It's like, let's not do this.
Right. That was kind of a that was a perfect example. I was teaching game engines in spring about what not to do. I guess.
I never played the game as soon as it went out on a PS4, and I had a PS5 and a PS4, and I was comparing them, and like it really is the vehicles, like the AI with
Yeah.
the people and obstacles, and the vehicles are like the murder points
Yeah.
of the game.
And the reality is a lot of those systems are where they're trying to do lots of stuff in parallel and stuff that gets kind of wonky when it comes to programming and getting it right. So I'm not surprised. It was an ambitious project.
Yeah. COBOL itself is a structured programming language a lot of times more, or at least it's written not a structured programming language.
Yeah.
So they don't have any objects in there usually.
Interesting.
Because the first object-oriented COBOL came out in 2002.
Wow. Okay.
You might be working on this because these systems are from 1960s and onwards.
Yeah.
So if you're working on like a 1985 compiler, which is like a pretty prominent compiler that had a lot of changes involved,
Yeah.
what's gonna happen is like there's no objects in it. So like if you try to do anything like that, you're gonna get snapped in because your boss is gonna be on the phone with someone, and like product production support team is gonna be on the phone with you. It's a wonderful time.
Yikes! Yeah.
Yeah.
I can imagine.
Yeah. So how was your time as a software engineer at your company with Intel?
I really enjoyed it. I've always had a good time, so it's always been hard to pick one or the other. Or every time that I've left, I guess I could have stayed, and it would have been interesting. Yeah, I mean, I had positive experience. Worked on, it was kind of cool because even the stuff last time I was at Intel was in 2016, and the stuff I worked on, it was cool. Like they just released it last year or so. So be working on the
server memory.
So I was working on what was called AVX 512, the sort of parallel instruction set. It actually had some problems with it, but I guess maybe that was my fault. But I don't know, it's cool to be around a lot of smart engineers who are sort of thinking 2 or 3 years ahead of time. That changes how you think about things a little bit and how you plan, and it's exciting to get up every morning and work on that kind of stuff. Intel's work culture was actually amazing too, as far as work-life balance. So that's the kind of thing I'd love to spend a year or sabbatical or something and go back. I mean, that's why I try to do consulting and those kind of things. But Intel is really good. Yeah.
The only things I could be able to know first of all would be IBM systems. That's really all I should be able to know. And they're not really that great because the only places that really use them are of course IBM, but the only place that really use them are typically government, insurance, and banking. And they're the companies that don't usually put money into their funding for technology. So you're kind of stuck with a lot of people who haven't really pushed themselves forward sometimes. And it doesn't, or have become complacent in their positions, such as in the government, even though they say they're promoting there, that's not true at all. Yeah. It's more by seniority. So who's ever worked there about a number of years,
I see.
is the person that ends up in demand. And users like even like a general, for example, who has no idea what it is.
Right.
That's usually how it happens.
I mean, that was one great thing about Intel. They encouraged you to move horizontally, of course vertically eventually, but every 2 or so years you're getting different exposure, different people, different, it keeps your energy up. Also.
So the technical program I originally learned, you would learn distributed systems and frames. Like you could kind of pick and choose what you wanted to do. They took that all out then. Every tech person was like, that's not a good idea.
Kind of kills the excitement, I guess. But all right, well, cool. Yeah, let's continue the discussion. Very cool. Alrighty, folks. Let me kind of keep moving us along here. So I guess one note I'll make too. Let me advance us to pointers. Just general class thing, I guess. This class does run till 9:15, which is a super late class. We will try to finish earlier than that in general. Just because, I mean, from your perspective, retaining 3 hours and 15 minutes of information is kind of crazy. But for some of these topics too, like I think I'm going to go through a little bit quicker through pointers. But if you say, Mike, I really don't remember pointers from systems. I've never learned it before. Right? This is your first time looking at this. Let me know about that kind of stuff. That's the kind of stuff I love to do. Either like a live session for, or one of these like YouTube videos like I sent out to just be like, here's everything you need to know with pointers, and then just doing a bunch of examples that you can sort of play around with and mess around with on your time. I think that's just a good use of time in general for me to do that, and in your perspective as well. So yeah, question.
Sorry, I always have the feeling that we should know it for interviews, but then
for pointers?
yeah, I don't know.
Yeah, I've been asked to reverse a linked list one time, so I can say that in systems. But actually, I'll take that back. I was asked to do like a swap before too, and so that's where it was important. I think they wanted to know if I knew pass by reference versus pass by value. So it does come up occasionally. Depends on the position too, right? That's the other thing too, just to give perspective. Right? We were just talking the gentleman here about different jobs, and to sort of reflect on my experience now, right? So you're going to get my bias from the sort of like somebody who went to work for Intel and sort of a graphics and this sort of perspective versus folks who might go full stack or distributed systems and have different set of importances you want to emphasize. Yeah, totally valid, I guess. But I will say at least what the value is thinking about memory, what you're managing, and when we eventually get to smart pointers, using smart abstractions to avoid, creating problems with, this thing that's confusing. Honestly, if I was in an interview, one of the questions you might ask is, well, do we have to use pointers? Can't we use this thing called smart pointers? Sort of going into the trade-offs there. Because otherwise on the interview it's just sort of trivia and what you remember and these kind of things. So pointers, just a little bit about them. Again, I'm going to kind of zoom through this, but I do sincerely want to know if you're just like, hey, I don't remember this at all, or whatever that range is. I think I'm going to do it anyway, and just make a video about pointers just to be safe. But anyway, pointers are other data types where you store an address, right? And we got to see that a little bit with this exercise. You can have pointers to any sort of data type, right? And here's sort of just the visual of the pointer on the right side storing not this value 500, but the thing that it points to, sort of abstractly this address here. That's what it's storing. Okay, and it's storing an address. Well, how do we do that? Again, with the ampersand operator. And again, I think of the ampersand sort of as a function that's returning the address of x every time here. Okay, so really this series is just sort of the creating a pointer. We always want to initialize our variables. In C++, we use null pointer. It's actual keyword in modern C++, so it's better than capital null. as you might have done in C. And then when you want to point to something, which we've seen the address of, and you can again verify this by just printing out the actual address. So if you just print out the pointer, that should give you whatever the address of X is, because it points to it here at line 22. Okay, and you can verify that. And then again, if you want to figure out what the value is, that is look inside and not just get the address, but the actual value of the thing that you're pointing to. We call that dereferencing. And again, that uses the asterisk, that star marker again, but in front of the value. So an example of that's at line 26 here, where we're saying, hey, give me the value of this thing dereferenced. Okay, so there's the output. Okay, so just a little exercise. Again, crash course reminder of pointers. I'll let everybody think about this example. And what's X going to be at line 25? Hold on to your guesses. So again, just walking through, we've got our main, our entry point to the program. We initialize X with 1, 2, 3, 4. Then we create another pointer. Again, I usually like to prefix variables with P if they're pointers. And then you say, hey, that's equal to the address of X. So it's pointing to this thing at line 17 that we created, that memory. So X at this point is 1, 2, 3, 4. And then when I dereference P of X, I'm dereferencing with the asterisks here, and saying, hey, look into the thing that I'm pointing to, sort of follow that path, go into the address of X, and set it equal to 70. So I do modify X, even though I'm abstractly pointing to it. And again, this is sort of the power of pointers, the ability for multiple things to look in and sort of share one value, and for that to change over time. Okay. So why use them? Again, you might need to use them as parameters and functions. It can be cheaper to just pass by copy a small little tiny pointer versus a really, really big object. Right? Imagine Facebook passing, a huge, the names of all their users or something in an array versus just a pointer to that array. It's much cheaper. So we have that option in C++. They're useful for data structures. And then when you're dynamically allocating memory, that is requesting your operating system at any given time, just saying, hey, give me some memory. Where's it going to come from? From the left, the right, wherever, you'll be able to point to it. So that's why we do need pointers. Okay, so that's sort of magic. But they give us this ability to pass data around, manipulate how we use it, build data structures, and sort of do some interesting work with them. But I will give the caveats again. We're going beyond. If you saw this in my C slides, we're C++ programmers. We're going to try to prefer pass by reference, because that's going to be safer. If we just need to modify something in a function, we just refer to the actual thing we want to modify, and save us from any null pointer dereference and stuff. All right. So some last bits on memory. So if you remember from C, malloc, and free, C++ has new and delete. Same thing. And in Java, you just have new without the delete. So again, why do we need all these things? It's for control, the ability to dynamically sort of allocate memory when we're running programs. So here's the scenarios. So here's some structure that I create, a vector, in this example, x, y, z, and dynamically allocating one vector here. There we go, line 12. And when we're done with it, we delete it. Okay, so again, we manually have to do this. So as soon as we're done with it, we delete. Here's another example. This time I'm creating 50 vectors. And this time when I delete, I do need to use a little bit special syntax here, delete with the two brackets here. And that means delete all 50 of these vectors that I've created. Okay, so we have to be very explicit. If I forget the brackets, then it just deletes the first one, and that's it. Okay, and then I've got 49 of these vectors here. However big they are, they're just hanging out forever, taking up space.
So we lose the reference to them.
And we lose the reference to them, exactly. Yeah, so that's the real problem. So when we're deleting, what this is actually doing is it's following that pointer. And if you can imagine it like a eraser or something on chalkboard, it's going over and saying, get rid of all 50. You know, mark those as free, they're available, that memory is gone. But if we just delete the first one, we sort of lose our paper trail. We just delete the first one and say, okay, we're done. And there's 49 things hanging out. All right, so those are just the observations about using bracket versus not using bracket. Okay. Yes, question.
So I've never used anything that needs to manage memory.
Yep.
What happens if, let's say, I make a lot of variables?
Yep.
And it's just some program I run for class.
Yep.
And I don't delete them.
Yep.
What happens after I run the program on
Okay.
my own computer?
Yeah, let's see. Now let's try not to crash anything here. But there's your correct.
And okay, so if I do something bad, how do I fix it then?
Yep. All right, so let's do something reasonable here, like 99,000 integers or something I just created, and I forget to delete. So I'm going to compile this. And should I run it? Should I risk, Now, this is probably a small enough thing that I'm not going to crash the machine and lose our recording. The recording is being backed up as we speak. But, I run it. Okay, maybe not big enough, but what will happen is the reality is while that program was running, even for the split second, it allocated, whatever this is, 99,999 times however big an integer is, so pretty big number of memory, I guess. And then the program finishes, right? We get to line 9 or whatever. We haven't deleted it. So just for that split second, the resources were gone. But eventually, the operating system will come back and say, hey, we're done executing this process, this very small process, and it will reclaim it for you, that memory. Yeah. Now, depending on what application you're running, so say this is something that's running for a really long time. So let's just say I have some loop here, while true, and then it's just kind of going forever. It's going to hold on to those resources for a long time. So if I'm doing a bunch of stuff on my machine, it's going to start slowing down because this one program is just hogging all these resources. Right.
Have we just created a virus?
Yeah, I mean, yeah. Don't open this program. Yeah, send this to your buddy. No, don't do that. Yeah, if you want an extension, send this to me and crash my machine. Yeah, so, I mean, out of curiosity, who took, well, I guess no one's probably taken systems with me, but has anyone heard of a fork bomb or these kind of things? Yeah, okay, so a couple of folks know that whenever that assignment goes out, like on Cori servers, like, the machines are running really slow. There's a reason. People are doing some resource allocation stuff, creating viruses essentially. Yeah, so I mean, this actually gets into a interesting question though. And today, I'm showing you different things, but just want to emphasize software engineering is all about trade-offs. So if you work as a game programmer, like I've done, briefly, you might say, well, what's the point of even deleting anything? Because that just takes up time, right, to actually do. And some programmers never delete. And that might be the right thing to do, right? If you're playing on a PlayStation 5, well, you're only doing one thing at a time. So why bother? You own all the resources. So depending on your domain, sometimes these things matter or don't matter. I will say delete for now for this class. In 99% of cases, but game programmer, maybe some other application, might not need to. So that's a good question. virus program writer, I guess, too. Don't delete. Oh. All right, so, and when we don't delete, we get what's called a memory leak. All right, so to avoid this, we do have something called a smart pointer. So I'll sort of introduce this again later in practice. So the thing to key in on is you can see at the top right, this is how we would sort of create one. So I'm sort of creating some structure here. We'll talk about templates, which means generics in Java. But I'm just sort of wrapping a pointer. And again, this abstraction idea. But you can sort of manage to figure out, well, is anything still using this resource? And this is exactly what Java is sort of doing. Or if you've heard reference counting or some of these terms, we're saying, well, if this memory is not used, then it's safe to automatically delete it. So C++ has these built in that we will take advantage of. All right, so closing thoughts here. Few ideas on naming convention. We got a little bit into the weeds here on things, on how they work. We'll want to use good abstractions, separate things out into interfaces, especially as our code bases get very large. And we'll sort of pick and choose the features that we need. Again, I showed you a lot of C++ today and in the previous video. You don't have to learn it all at once, and you pick and choose the things you need, even if the language is really big. So it's okay to only know 10% of the language. All right, so plenty of tutorials here, and I'll put a poll out this week or whatever, or just message me right away and say, oh, I really need that lesson on pointers to help me. Happy to do that. Okay, so where are we doing all this work? Let's kind of go to the grand finale here on GitHub. So our first break, where I had you download these repositories on GitHub. So how many folks, just to kind of raise a hand, are familiar with Git and have used it before? Okay, so majority kind of feeling comfortable. How about everybody close their eyes for a second? Anybody who's not used Git, raise their hand. Okay. So most folks are, well, everybody is comfortable. So happy to do more review on this. So you know about Git being version control system. Here's a tutorial if you've not used it or just want to refresh. I've got one linked on the course resources page as well, where I go into GitHub, do a push of a file that I've changed, and so on. So I'm going to kind of go through this idea here. Okay. Okay. And I think that brings us to the very end. So a few logistics things to take a look at. Your in-class activity, again, that's on the web page for our particular module. Hop in here, module whatever, or just click here. And you've got a little survey to complete by next week. Ideally, as soon as possible. This one's just a survey, and at the bottom there's a few free-form questions about what you're excited about or any accommodations. So the sooner you get those to me, the better. That's for our in-class activity. For our lab today, so this will be, take home. We'll split here in a second. That is found in the repository. I'm going to go ahead and just dive in here. And you're going to be doing a little bit of an exercise. The first bit is on Git again. So I know I went through what is Git part really fast because you're going to see it again here. And it's going to walk you through cloning your repository, pushing a change, and so on. Okay. You're going to have a small little change to make to a C++ file here. So you're going to do a little refactoring that I'm going to ask you to do. And I'm going to ask you to do that refactoring in a separate branch. So we're going to get used to a little bit of a workflow here. So again, Git is this tool that allows us to do version control. We're going to talk about this a little bit more. I just want to make sure people can basically push files, compile C++ code, and refactor a little bit. So that's the walkthrough here on Git, and then we'll revisit Git again and how people use it in practice. Okay. For the assignment 1, which you'll also find here and is due in 2 weeks' time, there's a few pieces. This one is primarily C++ training. So you're going to see Aaron, who's a C++ expert, and Peggy on pointers. Okay, so, and then I'm happy to do a lesson on pointers as well. And that's just to get everybody up to speed on C++ and give you a little bit of time on that. So those are 2 pretty good full courses that you can get started anytime as you like. Any questions on the first assignment and lab? Yes, yeah.
I have one with respect to Git. I mean, I use Git, but we kind of implemented really well by doing the retreat team. I know that when you do a pull request, for instance, and when you're merging, there can be like merge conflicts and all that stuff. I've never, like, I'm kind of afraid like being in a team and then go to do something and delete everything.
Yeah.
So I don't know.
Yeah. Let me point to, let's see, I think here, let's see. In today's resource, I think if you go to my video, let's see. Yeah, Git Beginner Masterclass. I got to think of better names for these things, but towards the end of it, I'll intentionally create a merge conflict and fix it. So you can kind of skip around in that. I'm going to revisit Git again. In fact, in the next lab, revisit it. Maybe I'll modify to make the merge conflict a little bit more explicit. You won't lose everything. So every time in Git when you do a commit, think of that as a save point. So commit often. And as long as you do that, it's saving things, and you're in good shape. This video actually might be in particular interest to you because I talk a little bit about what Git is behind the scenes. It's really just a file system that's sort of cleverly hidden behind the tool Git, I guess. So we could talk more about it, but we won't want to be afraid. We'll get practice. And there's a tool. Basically, it's harder to get rid of your repository as long as you commit often. We won't have to live in fear. Yeah. Git's really the tool that I wish I had learned when I was going for my first internships and stuff, because that was a scary thing. I was worried about deleting the entire code repo and my boss firing me. And, so that's one reason I'm forcing it early and often. Making mistakes here, not a big deal, right? We'll get the files back, or figure it out. If you're on the job at Google, though, bigger problems, I guess. Other questions or comments about logistics? Yes, yeah.
Do you want us to use Vim in all of our development, or can we use our own library?
You can use whatever tool you want in that respect. I'm going to, again, try to push us all towards Linux. So Linuxy tools are preferred. For folks who had me in earlier classes, I try to force Vim on you. But you're welcome to use CLion and these kind of things. I think that's fine, especially as you're going through the C++ exercises. Command line's great for really understanding what's going on, but you can use some other tools too. Yep. Yes?
In one of your videos, when you were talking about using VirtualBox, you mentioned having like an OS distribution already set up. Where can we find that?
Yeah, let's see if I have it in here already. I will have to push it up here. I don't think I have it right now. The next assignment or the next lab, I have a link to the VM. If you make a Piazza post, I can do that tonight or tomorrow morning. Yep. Other questions, comments? All right, that's it. I'd say class dismissed. I'll stop the recording. Thank you for your time and attention.